Hey everyone, my name is Adam Craner. I'm the energy consultant that's been primarily working with the facilities that we have been to so far. I know Amanda jokes around, Burlington's practically my second home at this point. Been doing a lot of work there. So, as far as everything Pete said, the daylighting certificates are there, but is it feasible in every place? Not all the time. So what do we start looking at as a replacement daylight? 120, 150 years ago, we started with incandescent. In industry, we went to maybe the strip lighting, the fluorescent. And then we realized we can knock a couple of those out and get some mercury vapor or high pressure sodium. Well, then the color doesn't really make sense. It's got that yellowish hue. So then they go to metal halide. What are the options now? There are some places that have gone to the more efficient version of fluorescent, and then there's also LED. So this is just going to be kind of more of a discussion on how does it affect the people at the plant from a visual standpoint. Poor lighting. It's been shown to cause eye strain, eye irritation, blurred vision, headaches. I think of the couple of facilities that I've been in of yours. The lighting isn't necessarily great, right? So you walk in, how comfortable are you? As Tim was saying, making the employees feel a little more happy to be there. When you're walking into a place that has that kind of tonality, it can create some of these backlashes. Brightness. Too little or too much can make objects hard to see. So in a situation like the picture up there, that's too little. That's not something we want to see. But on the flip side, we don't want to light it up either. You don't know if you're all from the Indiana area, if you see snow, too bright can be an issue. Not too much sun out, and if there's a ton of snow on the road, you're still wearing sunglasses, right? So, you can still incorporate task lighting where it needs to be. It's not a bad thing to have task lighting in the right places. It makes a lot of sense. Along that with contrast as well, which kind of comes with your color qualities. Too little contrast is going to make it hard to distinguish. So when you're looking at defects from a quality standpoint in the bottle, if there's not enough contrast, how can we expect the people on the line to see those defects? Preferably, try to see it as soon as possible, right? Not post-inspection. So what are some of the other issues from lighting? We were talking about OSHA before, right? Nobody wants an OSHA reportable. Big thing with them is 10-foot candles in the warehouse, minimum. Seems pretty easy, right? I realize my little circle there is up, but this one was supposed to be highlighting that it's in the warehouses. This right here is a one-for-one drawing of your Burlington shipping and storage warehouse. So, how do I start this up? This is around below 10-foot candles. So now this is all product, okay? We don't really need to worry about the 10-foot candles in this area. But everything here is where forklift drivers are driving. Along the edge here. Right. Do you guys see anywhere that's under 10-foot candles? Quite a bit, right? So if that's something that OSHA decides to start looking at, not good. We did this, basically a one-for-one drawing. We mapped out where each fixture was because we realized it was an issue. And that can come with, building add-ons, whatever it may be. 35-foot spacing here, 10-foot spacing there. Ultimate issue, not only that, so the OSHA, not good, but from our perception, when you're driving through an area like this and you see a high light level and then a low light level, the way your eye perceives that is just automatically dimmer. So if you can get a more consistent lighting, you can actually have a lower foot candle level and have the employee feel more comfortable in that area.
Is that measured or modeled?
Two different things. This is modeled based off of what was measured. Okay, so when we're looking at future, right, It's a model based off of reflectance values and things of that nature. What we do is, in this particular area, because it was such an issue, we took each area that we measured, which I actually have along if you want to see it later, and put it into the program and back it up. Okay, so then that way the guys at the facility could see what's literally happening at this time and place.
I think it, I used to be a plant engineer. And what they did in that warehouse, back in the late eighties, they did a lighting project. Then there was some warehouse manager came in and decided he wanted to redo the traffic patterns in that warehouse. Most of the lighting in that back half of the warehouse was sitting on the product. I mean,
Okay.
and it wasn't in the aisle, it was at all.
And that makes a lot of sense.
But they were lighting.
Right. And, I mean, the nice thing about these projects is, you know, now we can make it to where it's gonna be more comfortable because the pattern or the layout of the warehouse has been sustained for quite some time. So, when you think about it, 85% of the information you receive is through your eyes. Okay? From a lighting standpoint, how huge is that when you're looking at productivity and how everything in that area is perceived? 85% of everything that's coming in is through your eyes. So, spectral distribution. I put the long definition up on top, but on the bottom, it's how the light is emitted and how we see it. So everything Pete was talking about is dead on with daylighting, right? So how do we mimic that? What's the best way to mimic that? These are spectral distributions of different light outputs. So you can see how daylight is here. And he's already mentioned the, that's what we're used to seeing and has been for the last hundreds and thousands of years. Obviously, when we're looking at the high pressure sodium, that spectral distribution does not really line up. Metal halide is a little bit closer. We have more color distribution. Now, when we're looking at an LED, mimics daylight quite well, with the exception of a little bit of the green color value. But beyond that, LED is going to be the most, or the closest to mimicking a daylight. So the big thing with LED, and actually, Tom, you and I were talking about this last week, photopic versus scotopic. Light meters see light as photopic. With the color rendering of the new technologies, it's not always enough. When you see a foot candle reading being lowered, it's not always a bad thing. The human eye is going to be a better light meter at this point than any gadget. Okay. Now we use it for measuring because it is a must for before and after. But high pressure sodium actually. Anybody like working under that light? Anybody? No. Foot candle readings on those things show up pretty dang good. We could probably reduce it 5 or 10 foot candles with an LED, and you're all going to tell me it's much brighter. But the meter is going to tell me otherwise. But ultimately, what's going to make the difference? How you feel in that area, right? We haven't had anything so far where the foot candle meter has actually showed up less, but it's something to think about. It's just how the eye is perceiving the light, and that's what we're more worried about, is how people feel in the facility. Slip strips, falls, poor lighting in bad areas, you know, kind of self-explanatory. If you can't see something, you bump into it, boom. That's a whole nother issue. So this is just kind of the safety and security side of it. The two facilities I've been to so far have smaller parking lots. But if you have something that has a bigger one, think about the safety and security of the employees that are going in on third shift, 10 o'clock at night, right? If you've got some older technology where, if we look at the light spread here, it's not something anybody's going to really feel safe getting out of their car. I don't know where all the facilities are. Maybe they're in better areas, but never hurts to make them feel a little bit better. Productivity levels are about 5% lower with outdated lighting. IES, we got the book here. So this is the book that is our guideline for building lighting standards. If anyone wants to read it, it's a pretty quick read. Maybe a nice. They recommend 20 to 50 foot candles in glass manufacturing for the annealing inspection and furnace areas. Right now, in Burlington, you're averaging 7 to 18, which is an average of 12 and a half. Now, it's not as critical as when you're looking at the OSHA standpoint where you get fined for it, but when we're looking at the idea of productivity, the quality, the IES is been built for many years with a lot of professionals. There's a reason that's there.
What's the OSHA level?
The OSHA level is 10. So here and that's in warehouses. They don't really have anything that's specified towards production because most facilities have their production is lit up. And maybe I just haven't been able to find it. But the warehousing one is the one that seems to be the bigger issue.
What's IES in?
Illuminating Engineering Society.
Thanks, Sam.
And we're, the certification is called an LC, Lighting Certified, and it's a tough test. It's a once a year test in November, 7 locations, same time test. Pretty big expertise.
You know, there's warehouses we have that don't have, the lights don't come on until, detects the forklift coming through the eye.
Right.
I mean, that's how we're conserving energy. So why would you need lighting on all the time? I mean, we're not talking about that, are we? I mean, you're talking about sufficient lighting when you're occupying the area.
Correct.
Okay, otherwise, we could turn those lights off as well. because
Yes.
We don't need it.
It's when it's being occupied, when there's a workforce in the area, that's what's creating the issue. You're dead on.
Okay.
Are you going to get into that? I mean, because LED probably doesn't have the restrike issues that metal halide does or whatever, right? A lot of
Correct.
sensor stuff.
LED is instantaneous, and quite frankly, the way they're built, it actually increases their lifetime the less they're on.
When did you do this study in Burlington?
I've been working with them since December. I think our full-blown audit was February, March timeframe.
Who's them?
Excuse me?
Who's them, the person you're working with?
George Anderson and Mike Kerrigan have been the main points of contact there.
When you, in the Love Center, we just did two palletizer projects. And over those palletizers, we changed out the sodium to LED.
Yep,
And were they up when you audited?
there was a handful,
Yeah,
5 or 6.
I think there's 9 of them, 9 or 10.
Right,
So they were up when you did your audit.
yes.
I'd like to look at that data.
Okay. And that's another thing to mention. Those were glass, correct? Last we had talked, the food portion, you know, like Burlington does the pickle jars, so it's considered food. You got to wear the hairnet and the beer net. Last we were under the concern was it was no more glass in those facilities, obviously besides the stuff you're producing. So that is something that we're looking at because I'm not sure where you're getting those fixtures, but there's different options to make sure that there's not glass hanging above. It's going to mix in with your product if it breaks.
To your point, LED has protective polycarbonate, non-glass, whatever lensing system.
Yes.
Because the actual refracting lens or whatever is glass, right?
The optic?
Not.
Yeah,
Depends on fixture.
June's gonna get really in depth with
Okay.
that.
Fine.
Polycarbonate is very hard to get and very hard to find, so you're very limited on the manufacturers to be able to use to that. But you're exactly right, you know, as far as glass and stuff like that, probably 90% of the probably 99% of the manufacturers issue with glass. because you have to look at, and I'm stealing some of June's thunder, is if you look at, I'm gonna say it, salespeople marketing, you're gonna wanna go after the most efficient light fixture. You're gonna wanna go after the most lumens per watt. And you're gonna wanna go after the longest life that they're claiming. And June's gonna say it, that's really not true. You really need to dig into the driver life, and you really need to dig into the material, because those are glass fixtures, and you gotta concern there. And if you're just buying the product and not digging into it, you could be making a severe mistake. There's data logging as far as temperatures. There's data loggers right now at Burlington yet.
Yep, we still got some heat loggers up.
We need to know what the temperatures are in the facility, because you put a $3, $4, $5, $1,200 fixture, whatever the cost is, doesn't matter. You can eat those things up, and in a year or two, you could be buying new stuff.
So June, who's June?
June is right here.
You wanna get into that?
He is.
So, because the normal ambient for that is what, 40C or 55C or?
You're right. 40C is typical, and 40C is what is that, like 120 Fahrenheit? No, 104. You're right. 104.
Yeah.
And 50C would be about 125, and then 60C would be around 140.
Yeah.
So we have all those temperature loggers for at Burlington and stuff
Yep.
like that.
Just kind of go back to the safety and security, a simple one-for-one, just kind of looking at the, how the light spread comes out. Again, he was talking about the optics. Optics on some of these newer technologies can create a much more comforting environment. This, as we talked about before, this is a rendering based on size. Remember, the IES recommending is 20 to 50 foot candles. The solution that we're putting in Burlington is going to be about 35, right in the middle.
So your Burlington solution, are you generating a lighting standard that will be adhered to by whoever provides the fixtures, or are you repping the fixtures?
That's a great question to ask. I'm actually walking through with Tom tomorrow to help develop that standard. We're going to be going to Winchester, and I know Tim's been talking to George about that over the last few months. That's the biggest thing, is part of these projects is what kind of standard are you guys going to hold yourselves to? So we're going to be taking some levels and starting to develop something from there.
Well, maybe Jude's covering that, but are we not doing more of this than we do? Are we not better off having a lumen lighting level standard with performance over time requirements and staying out of, I don't care who's providing the fixture?
Yeah. No, you're dead on. And that's the part that's important to your production.
You don't want to be limited to a particular manufacturer, right? Let the best product win.
Right, that's
Who can
the
get
game.
the job done?
What little I've been involved in this past, that's the game you get into. Everybody wants to rep their product, and that's where the revenue is and whatnot. You can't waste your time doing studies and stuff, and you don't get any revenue either. So Wasmer doesn't rep lighting companies then.
We do have lighting manufacturers that we work directly with the manufacturer. We do, but when you're doing, if you go back one slide, so that's a 3D rendering. That's a modeling, 3D rendering of a facility, 3D model of a facility with the pseudo colors. So what you end up doing, if it's, let's say you're a tire manufacturer, glass manufacturer, whatever, you put the CAD drawing in, you put different fixtures in there. Some fixtures just can't spread the light based on where the grid is. I think there's a select number of manufacturers you want to limit to as far as good brand of drivers that they're using, things like that. You want to limit your exposure to 20, 30, or 40,000 different manufacturers. But when we do engineering projects, we pretty much know based on the temperature what fixtures can handle that area, what fixtures can spread, what optics you put in there. We put it in the spec, and usually what we do, like Burlington, for an example, if I can just get into the nuts and bolts of it, we put in different manufacturers into the spec. We have some fixtures hanging. We walk three electrical contractors through at the exact same time. They all got the same scope of work, and they all sent back a bid based on the labor installation to do the entire entire project. We want to take out the commodity pricing and get rid of that sales approach. Let's get to the nuts and bolts, let's find the right manufacturer for the lighting, the right labor to get the job done, and spit it out. That's what we did. Did that help?
Yeah.
Perfect.
Yeah, and further to your point, we're agnostic when it comes to manufacturing.
Yes.
So it's all about the performance and trying to achieve the end result.
June will probably get into it, but there's also remote ballast opportunities too, right?
Right.
Projects also evaluate the surface finish of the roof. You know, we've talked about adding daylight, we've talked about adding fixtures. You know, the reflective qualities of what's up there hasn't been talked about, and it can add significant value to reusing the light multiple times by, you know, the diffraction of the light. Is that part of this, or are we just gonna solve it by strictly putting in lighting and skylights, you know, is that the question? Or are we gonna do this more holistically? 'Cause I know of projects that half the solution was just recoating or refinishing the area.
Are you talking the roof, or are you talking the decking? Or
The
both?
The underdecking. You know, we had a project in Seattle, half the success was driven strictly by cleaning the roof, painting it bright white, just doing that, people went, oh, we really need to do the lighting project. They did the full project, but the finish was everything.
Yeah. What I would say is, based on that, think about who your clients are walking through the facilities, and think of your employees walking through the facility. What can we do to try to increase revenue, maintain employee retention, reduce your energy costs, things like that, have a holistic approach to it? What's the return on investment on that? Value engineer some of those things out by, you know, walking through multiple contractors through. Let's try to get it as smart as possible, and then let's move forward. Does that help?
I mean, I know what you're saying as far as the aesthetics go, but I think what Dave was driving at was, I take a dingy, black, darkened room, and I put in nice, much brighter lighting fixtures to get this level at the floor level, as opposed to option 2 is, it's a new paint, reflective, and a different light fixture to still arrive at the same conclusion.
Oh, absolutely. So what those 3D drawings, you put in reflectance values of the floor, you put in reflectance values of the wall, and you put reflectance values in of the ceiling. You know if you change the color of the ceiling from black and dingy to white, which would be above 40% reflective, you will change the light levels, guaranteed, and you can go down to a smaller wattage fixture maybe. And yeah, absolutely.
So you've had recommended solutions where that was a piece of it.
Yeah, so we only like to work in places where you have to wear hard hats and steel tips, safety glasses. That's where we love to work. So foundries and stuff like that. There's a great foundry like Brilliant, and that was part of the scope, is to make sure that the walls were painted, pipes were painted, all that stuff at the exact same time. They painted the ceiling first with the old lights in, and then came in with the lights after.
Another benefit of that is from the maintenance side of it. Parking lot lighting, with outdated parking lot lighting, maintenance costs were 197% higher than with LED. Frankly, from the maintenance standpoint, you're just not touching them anymore. A lot more time they can be spending out on the floor. Typical metal halide repair kit is about half the cost of a new LED fixture anyways. So I know you had mentioned, well, we don't have to replace the lighting, we can just do the paint. It is great, but once you replace the lights twice, you've already paid for your fixture and wasted a ton of energy in the meantime. Just to make a little bit of more sense from the glass side, if you look at this 5% non-metallic mineral product manufacturing, this is the energy share from 10 years ago or so, but it's the energy share in industry in the United States. If we break that out, 2% of that is glass manufacturing from purchased glass, 9% of regular glass manufacturing. According to Energy Star, glass manufacturing is 1% of all energy States. That includes residential, industry, manufacturing. That's a lot. Lighting itself consumes about 35% of that electricity. Motion sensors, the lighting's going to be a little less in your guys' facility with the high energy use of the furnaces and the air compressors. Motion sensors can help optimize, as we were discussing before. It is crucial, though, to make sure that you're putting it in the right layout. Like we said, if they're not coming on at the right time, you can have more safety issues than you already did. How do we know if they make sense? Put loggers in. No different than the electricity side of things. When we're looking at this, we want to make sure that we're putting them in the right areas. It doesn't pay to put it in a production area that's running 24/7 if there's never a body that's out there. And this keeps the guesswork out. If you tell me they're in there 20 hours a week, I can find out exactly how often somebody's walking through and how often the lights are on. This is just a little example here. This was from Burlington, out by the furnace area. So this is basically what it spits out in the end. It's telling me 50% of the time lights are on and there's somebody there. 50% of the time they're on and nobody's there. Well, if we're looking at a replacement that doesn't have the restrike time and we can turn it on and off as many times as possible, this makes sense to put a motion sensor on. On the flip side, this is from Milford, production area. Do we put controls in production? This particular one, when we installed it, it wasn't looking at the lights, but we were insured by their facility operations that they do not turn the lights off ever. So if you look at this, it was occupied 158 hours and not occupied 0.78 hours. Does it pay to put a motion controller in that area? Does it pay more for that? Absolutely not. It doesn't make sense. But we have the proof behind it. Did you have something? Or? Temp in your facility is huge. Absolutely huge. You guys have very warm facilities. As Tim and Juno hit on a little bit later, LEDs can be a little bit finicky with heat. So we put these in critical areas to ensure that the solution that we can provide is going to make sense and is going to be a long-term solution, not a short-term solution. Actually, in Burlington, we're able to prove out the fact that we can raise the fixtures 5 feet and still make sense because they don't have that wall blocking from the furnace, or the leers, so that heat ends up transferring into the ceiling of the production area. Last but not least, does LED work in all situations? No. This is a heat logger from the Burlington facility up on the upper mezzanine above the molding area. Below is part of our scope of work. I just put a snapshot in there. When we go through, we'll reballast and relamp metal halides, but quite frankly, there's not a solution that isn't going to burn up relatively quickly. And this is why we do the data logging. If I put something in there and 6 months to a year it burns up, that's not going to look any good.
So this is the area above the four-horse?
Yeah, this is where we work. No, it's above the
It's
machine.
above the four-horse.
Above the machine.
Yeah, it's above the machines. The graded area.
Around the four.
No, keep those LEDs in the hot end and they're working out pretty good.
Well, and there's different, so in like the furnace area, I know I gotta get going here. In the furnace area, they have them hanging from the ceiling. Now, due to the heat, we're actually gonna be putting them out on the wall and bringing the light in because the heat isn't as bad there. We can do that in some areas in the furnace, or in the forehearth area that you're talking about, but there are just some spots that it's not feasible, and makes more sense to just relamp them for now, and from an energy standpoint, to do 15 of them and just leave them be, it is what it is, I guess.
You're saying you really don't, it's not an opportunity to use the remote balance feature of the LED.
So if I can expand on that, so the weakest point is the driver, right? And that's, the driver doesn't like the heat. If you put up an LED fixture in this area, absolutely it's gonna work. It's probably gonna work for about, on that temperature, June, 30,000 hours? So based on 8760, you're calling 9,000 hours a year almost, 8760, the lights are running 24/7. That light will,
2.5 years.
yeah, something like that. It's gonna run 2.5 years. That's on an average. So some might last a year, some might last 5 years, you don't know, that's the average. There are things you can do to be different, right? You can remote ballast.
Yes,
You
I was
can-
gonna answer that, but.
Yeah, you can remote ballast, that's a great idea. You can dim the lights down and underdrive the LED, because when you overdrive an LED to try to push light down, that's what produces a lot of heat. There's a lot of those